Welcome and thank you for your time today. We know that these are unprecedented times that make it difficult for people to attend, and we sincerely appreciate it. I'm Brian Trenham, and alongside me is Jeff Fawcett. We work for a federal partner called CTG Federal. I live locally in the Maryville, Tennessee area, where I reside with my beautiful wife and children. I have 15 years experience working with the federal government, previously as an employee of an NSA facility, where I was principal architect for a data center. I moved over to CTG as a technical account manager and has since taken on the role as an account executive for East Tennessee federal agencies. I'd also like to formally introduce Jeff Fawcett. Jeff is our network and cyber principal architect for CTG. You want to say a little bit about yourself, Jeff?
Absolutely, and thanks for the introduction. So we're excited to be here discussing such an important topic. My name is Jeff Fawcett, and I've been in the DOE and NSA complex for the past 12 years. My family has a deep-rooted history in the complex, with my dad working for NNSA since the Reagan Star Wars days. And I reside in Greenville, South Carolina with my amazing wife and children. Previous to that, I lived in Northern California, where I was domiciled at Lawrence Livermore National Laboratory. So I was hired by CTG to build up our network and cyber architecture practice, and have had the privilege of architecting some of the most secure, high-performance networks in the world, spanning over 10 agencies. I recently authored a framework specific to federal sciences that we call the Federal IT Manhattan Project. And maybe you can tell us a little bit more about CTG while we're at it.
Yeah, thanks, Jeff. CTG Federal is a partner that provides cutting-edge IT solutions to advance the agency's missions. One of our primary focuses from day one has been the Department of Energy and federal sciences as a whole. We have partnered with the majority of the federal entities in the greater Oak Ridge area, as well as nationwide. Perhaps most importantly, we want to communicate our deep-rooted commitment and ongoing investment, both tactically and personally, to the mission of Oak Ridge agencies.
The intent of this presentation is to discuss the tenets of multi-domain architectures and how they're the most thorough path forward for a zero-trust architectural posture. These tenets enable unified policy across common and uncommon enterprise architectural boundaries, providing a robust mechanism that enables day zero, day in, and day two operations in unparalleled fashion. The phrase zero trust is the new next gen, often overused and lacking standard definition. You'll find different verbiage describing different controls related to zero trust in several of the latest federal mandates for IT compliance. We find in the CISA guidance related to the most recent widespread attacks affecting federal networks. We find it in the Technology Modernization Fund and its core tenets. And we find it in the recent executive order for improving our nation's cybersecurity.
Federal cyber analysts and management understand well the compliance issues that we must operate in. Often enduring several audits a year, the gathering of traditional audit data to stitch together into a compliance package is exceedingly cumbersome when an agency deals with multiple governing standards. Though many controls overlap, there have historically been a significant difference between control groups. So as we look at the latest federal IT modernization mandates, the compliance standards that we are subjected to, like NIST, FedRAMP, and ISO, and the very public nature of FITARA, it's critical that our whole of our architecture enables stability, security, and continuous compliance.
Recent attacks on our national infrastructure are top of mind. In Cozy Bear, APT-29, Dev 0322, we see major OEMs suffering significant compromise. We now live in a new normal where we can no longer trust implicitly the software supply chains of our partners. The traditional way of connecting networks and workloads just don't provide us the dynamic capabilities needed to support rapid deployment methods, the unified golden policies of day in, and the agility needed to deliver the rapid remediation of threats. These traditional methods obviously don't meet the needs of the federal IT enterprise any longer. Adopting a zero-trust approach via different bolt-on solutions is unsustainable for most organizations that don't have a robust automation team. So what do we do with that? How do we provide solutions that meet all of those aforementioned demands while providing us the deep visibility needed to detect common threats, complex threats, and the ever-growing threat of shadow IT, both on-prem and in the cloud? This is where multi-domain becomes an imperative for federal IT enterprises. And this is where CTG's IT Manhattan Project framework delivers unparalleled value specifically to federal science agencies. So continuing and building upon the multi-domain story, Brian and I are going to have a short discussion of some key points and how they integrate into the whole big picture. So Brian, if you wouldn't mind me starting asking you a question. So you interact with customers more than anybody on a day-to-day basis. What kind of challenges and overall discussions have you had with them related to securing their networks that a multi-domain approach might solve for them?
That's a great question, Jeff. Some of the traditional issues vary, obviously, but those include lack of staff, lack of training, and a sprawl of tools in their kit to actually solve those problems and managing those additional tools. Obviously, with the new threats, they're becoming more advanced and complex on a daily basis, so that only reciprocates and continues the issues that they have from the traditional model. Which that kind of leads me to a couple of questions I have for you, especially with multi-domain. What are some examples of common enterprise boundaries that multi-domain principles affect?
Sure. So common enterprise architectural boundaries would be, things like data center, enterprise networks, cloud, and then, extended enterprise solutions, OT, ICS, IoT. The problem that we run into as architects when we're architecting for security in those domains is that traditionally we have different tools and different ways that we apply, posture and profiling in those, compartments. And so they are done in a silo or a compartment. Really what we're trying to do here is provide integrated fabrics that go across those domains, provide different policies, different application profiles, et cetera, but do so in a way where our security posture and the way that we orchestrate across the enterprise is done in a more holistic approach that's stitched together across common fabrics.
That makes sense. Well, what are some of the basic tenets that make up those multi-domain architectures?
This is an interesting question. So there's still a robust, reliable underlay. And a robust, reliable underlay is going to be real similar to our common IP transits today, right? Our layer 2, layer 3 switch routers, et cetera. The power comes in the form of a highly orchestrated programmable overlay. So what we're using there is really programmable encapsulation methods like VXLAN, Geneve, et cetera, where we can take that and we can edit the headers and metadata and program those in order to do different things. We can inject security tags, et cetera. And then more than anything, we operate top-level enterprise orchestrators. And that's where we perform this cross-domain orchestration, right? We can run runbooks and playbooks that go across those main architectural boundaries and provide more of a unified fabric with unified policy, unified things like QoS, et cetera. You can see the power in that. And then lastly, when you start injecting automation, right, you're injecting continuous improvement. You're improving upon how you run those runbooks, partner integrations, to provide a more cohesive framework. And the more you're dumping into it, right, the more that continuous improvement happens. It's an interesting situation.
Yeah, sounds really interesting. With that said, earlier we were also talking about compliance standards like NIST and FedRAMP, right? How does a multi-domain approach simplify meeting those necessary controls in like a faster and more efficient manner?
Sure. So again, the multi-domain approach focuses on those top-level orchestrators, right? And so as we're working from the top down or designing from the top down, we see those top-level orchestrators that have visibility into each of these domains, right? They're reaching out and touching these domains. But how do you take those and then control visibility, right? Because you can only manage what you have visibility and management access to. So how we do that is we open up these streaming telemetry streams. So these switches will offer a subscription up to the top level orchestrators and start streaming operational data. So historically, we have network technicians, network engineers who are going into each switch and looking at for errors, CRCs, beckons, et cetera. Those engineers now see it on a dashboard, much like a knock or a sock. And then I'd say lastly, when we add things like machine learning and couple that with traffic analytics down at the edge, we start seeing higher visibility, higher opportunity for assurance, and then a byproduct of those things is monitoring for continuous compliance. And that continuous compliance can be, constantly reported on up to IT operations dashboards, so that our upper management, our cyber management, has an up-to-the-minute visibility and metrics, so that it's predictable when those auditors come in.
Great, thank you for that. Maybe we'll do a little bit of drawing and better understand.
Absolutely.
We've been discussing a multi-domain approach. We'll now allow Jeff to draw up that architecture.
Absolutely. Well, so multi-domain means there's multiple domains, right? So we'll start with the data center. We'll have the enterprise, and then we might have the extended enterprise. All right, so what type of stuff would be in the extended enterprise?
In the extended enterprise, we're probably looking at PLC, different production, and controls that are generally outside of the IT purview.
Excellent, and those would be, our non-standard protocols, things that aren't your traditional, IP protocols. So we'll just say like building controls. Okay, how about in just your standard enterprise?
Enterprise would be your networking generally for the campus as a whole, building, Wi-Fi, those, etc.
Yep.
Correct?
So in those, we'll have common, your cores, and then those, there might be a distribution layer, and then those will go down to building switches, right? So this might be your red, net, and that might have HR handling off of it, and then you might have, another one. We'll call this engineering. How about data center?
Data center has your traditional workloads of virtualization, as well as servers, storage, and backup appliances generally.
Absolutely. And data center is a place where virtualization is a lot more mature, right? We've been doing virtualization for a lot longer, say vCenter, vSphere, right?
Correct.
Okay, so over here you'll have, like your blade center chassis. You'll have pizza box servers. And then to your point, we have storage, right?
Correct.
Okay. Okay, great. And then we have a WAN out here, right? And your remote sites might connect to your WAN. What else would connect to the WAN?
The cloud, which is becoming a major factor in these environments.
Yes. So I guess for the purpose of this presentation, we can just use Azure as an example.
That sounds wonderful.
Okay, we'll draw Azure up here. And what are some things that you would run in Azure?
You would run containers or serverless workloads, a lot of SaaS model. You would also run Azure AD.
Exactly. Right, so Azure AD, function apps, right? Serverless, etc. Okay, so we've kind of pointed out how all of these go together, but normally we'll see different teams managing different environments, and why would that be?
Well, in the traditional format, there's not a lot of overlay. So a team may run this extended enterprise, which is so different from the enterprise, which is so different from the data center.
Absolutely. And that's where we want to break it up into more of a simplistic model, right? In the past, we had kind of a 3-tier architecture, your core, distribution, access. Well, now we're going to look at it more from a top-down approach, okay? So we're going to have an orchestration plane, a control plane, and a data plane, okay? So the idea from an orchestration plane standpoint is we want it to enact policy down, right? So let's draw an orchestrator. All right, what that orchestrator does is it provides a single pane of glass for your NOC, your SOC, you know. And so for the NOC, they're going to be more concerned about IT operations, net ops, right? People are reporting, server guys are reporting latency, and it's always the network, right? Or from a SOC perspective, just collecting all that intelligence and looking for, you know, APTs, you know, malware, et cetera.
Abnormalities.
Exactly right. So in order for the orchestrator, number one, to start building this out, we have what's called a day zero templates.
Okay.
A day zero template is basically think zero touch, but it will use a kind of a global policy, which would be your kind of baseline configs, right? What goes against your STIG configs, et cetera.
Golden image, if you will.
Yeah, golden image. And then it will push that down, right? So it'll stand up switches here, border switches, and it'll ingest it right into the orchestrator, right? Okay, same here, border, and then border. All right, well, this is great and all, but the next piece that we want to provide is workload mobility, right? We want to be able to move from here to here, you know, here to here, et cetera. And if we want to pick something up and move it, we want to be able to, right? In the past, we might have to span a VLAN all the way across here, broadcast storms, meltdowns, et cetera. So the way we do that is to break it up into pieces, right? We call this the orchestration plane. Then we have the control plane. And then down here, we'd have the data plane. All right, so again, from an orchestration standpoint, we want highly programmable protocols. An example might be VXLAN, right? So in Cisco campus environments, the underlay here would be VXLAN. And that handles your data plane stuff, right? And then over the top of it for your layer 3 workload mobility, extending VLANs, the EN side would use what's called Lisp. Okay. And it's very similar for the data center or EN, right? VXLAN, VXLAN. So the point is these are all three of these are different fabrics, right? But they're managed by common policy. Okay, so feeding into our orchestrators would be our policy, right? Those would be our crown jewels like your CA, PKI, your AD, your LDAP, your radius, stuff like that, right? And so all that policy that would be top level crown jewel policies feeding into this orchestrator so that when a host comes online down here, one of the first things we enact, right, is admission. And then based on that admission, we go authorization, right, posturing, profiling, et cetera. So as you can see, it's a top-down policy approach feeding into these programmable fabrics. Does that make sense?
Totally.
Okay, so ultimately the last piece to this would be how we can turn this highly programmable overlay into OpEx reduction, right? And that's a problem that we brought up earlier, right? Less staff, shorter time, right? So how we do that is, one way is to have telemetry. So a telemetry appliance might subscribe to a switch, and then we request what's called a subscription. So streaming telemetry from the underlay and the overlay are constantly reporting back and giving ourselves IT ops intelligence and cyber intelligence in terms of flow analytics, et cetera. And then based on those, we can build triggers or playbooks up here to say, hey, if we see a high number of CRCs from a NetOps perspective, bounce the port, right? Stuff like that. If you were an engineer training a junior technician, what would you do? You would teach them, right, the basics of how to remediate things. And that's kind of the beauty of telemetry. Last thing is we're gathering machine learning data, right? We're gathering the ML, and then we're feeding that up as well. And then ultimately, we're using that and using AI to convert those things, right? So as we're building this, we get to insert automation feeds and stuff like that, right? Automation is kind of that final piece. And so our NOC, our SOC, our programmability experts can build automation to continuously improve the environment. So that's kind of the beauty of multi-domain, single pane of glass, single place where we originate policy, single place where we initiate things that go against STIG and compliance. And the whole of the enterprise starts to be a lot easier to operate and automate.
Thank you again for your time today. This is Jeff Fawcett, and I'm Brian Trenton with CTG Federal. We really appreciate you taking the time to walk through this with us. Our information is on the screen, so if you have any questions or anything you'd like to discuss, feel free to reach out at any time.
Absolutely.
Thanks again, guys. Bye.
Thank you.